Okay. Okay, so start recording. Awesome. So hi everyone, I'm Rob, and if you don't already know me, I'm a second-year computer science student at the university, and I'm also currently standing as the lead for Google Developer Student Clubs at the university.
Hi guys, I'm Leela, and I'm a second-year computer science student, also a core team member of DSC. And when it comes to Git, I remember it being really intimidating in the beginning of first year, but I've gotten around to understanding it and using it a bit better now. So I'm here to uncomplicate it just a little bit for you guys.
Justin will also be here. He's the DSC lead from last year, and he'll be around. He's a whiz in Git. He knows everything. Well, I say he knows a lot about Git. Yeah, I would say. So he'll be around to help answer questions. So if you do get stuck or you just really want to ask anything in general, feel free to pop a question in the chat and hopefully he'll get back to you as soon as he can. So yeah, go ahead, Leela.
So you might ask, why do I even want to learn Git? Even as a student, if you've ever had a moment like I've lost all my work and I have a deadline tomorrow, Git's perfect for you because it helps you save all relevant versions of your code, and it's used by any professional developer when to just save all their projects. And it's just an easy collaboration tool, and you can share your code very easily with others. So yeah, that's why they use Git. And the thing with Git and GitHub is you might get confused between the two terms. They're used interchangeably, but there's a massive difference between them. So Git's a distributed version control system that keeps track of all the changes you make to a certain set of files. So you initialize these files in some sort of way, but Rob will go through that later in the live session. But yeah, basically, Git keeps track of a set of files, and it keeps track of every stage of the development process, so every version that you want to commit. It's also just called backup on steroids because it's a very, very powerful tool. Yeah, and it's also mostly used by software developers to, when different people are working on the same source code, this makes it very easy to just collaborate. So that's what it's mainly used for. But even as a student, you can just use it for personal projects to keep multiple copies, and you'll never lose it because it's there online. Then GitHub. I have a good analogy to help understand GitHub and Git. You can think of GitHub as a Google Drive or OneDrive online. So you can just save all your work there, and Git as a sort of an external drive where you save your stuff. So having GitHub is better because it's obviously online and it'll be there forever. So GitHub is a cloud hosting service. It's a cloud-based hosting service that lets you manage all your Git repositories. So if you have any open source projects that use Git, GitHub is just designed to help you manage those projects in a better way. So in short, Git's the tool and GitHub is the service for managing all your projects. I hope that analogy made it a bit more easy because I get that it's confusing, the two terms. For a little bit of history, so Git was initially created by Linus Torvalds when he was developing the Linux kernel. So he needed a way to allow other developers to also work on its initial development. So that's why he created this tool. But he turned it over in July 2005 to Junior Hamano, who's a major contributor to the project and the co-maintainer of it right now. So Git, the great thing about Git is it's completely open source. But GitHub, the hosting service, it's owned by Microsoft. And there are many other alternatives to this hosting service, like there's GitLab, which is also open source. There's also Bitbucket. I think there are many other services too. I don't know all their names, but yeah. So in what's common between all of them is that Git's the tool. Like they all use Git, but none of them own Git. Again, like Git's just the open source project.
So yeah, I know that a lot of people say, well, I've heard a few people say that Git is easy to learn or things along those lines. But really, I think that anyone who says they fully understand and know Git is probably lying. There are so many features, it can sometimes be really hard to wrap your head around them, wrap your head around all of them. But that's why we're here with this workshop, to try and help it make a bit more sense for you, and give you a basic skill set to get practicing and start on your path to mastering Git. And admittedly, even I don't know at all of the commands or features of Git, because there are so many. I only know a small subset that I use frequently to get what I need done.
Yeah. So if you're ever just starting with Git, there's a lot of terminology that just puts you off immediately from learning it, because it just makes it sound way more complicated than it is. So I'm just going to go through the words and make it more intuitive to understand, because the process that is the workflow of Git is very intuitive if you learn it, and hopefully this will make more sense. So first we have the repository, which is a data structure where Git stores all its metadata to basically keep track of all the files and directories. And also it keeps track of every version of the file, like all the changes, like the history of all the changes made to the file. So if you need to roll back to any previous version, you can just do that very easily. But to make it simpler, repository is just a fancy way of saying like a directory with a couple of folders that Git is in, so it keeps track of it. And then we have commit. Commit is a term used to save any changes. And so if you want to permanently store any changes in your project, you use the commit command. But again, Git makes it nice because you can add messages to every commit, personalized messages, and you know what every version of your code does. And there's also a two-step process to committing. You don't have to commit your entire project immediately. You can only commit certain files or certain changes. And this is done by a git add command, which we'll go in detail later. It might sound confusing for you now, but yeah, so you kind of stage the files that you want to commit, and then you commit them. So that's what commit does. Again, commit doesn't put it on the online server immediately. It just stores it in your local computer or your yeah. Then there's the push. Push is interesting because push pushes all your local repositories to a remote repository. Remote repository is an online service, a hosting service like GitHub. So it transfers all the commits you've made on your personal computer to an online platform. Like, yeah. And push is a command that's capable of overriding any changes you've had before. So you should be cautious when you're using a push command. There's also ways of backtracking and commands for that, but we won't get into that because that makes it complicated. I've used the word remote a lot, so let me just explain what remote is. Remote, again, is just an online place where a repository, it's a shared repository, so any person working on the same project also has access to this, and they can collaborate and share their code there. But it's also just a way for you to back up your code online. And you obviously know about GitHub, and our university also uses GitLab, which is their own server that I think most students use too, so you're familiar with it. So all of these are just remote places that you can store your code on.
So Leela's gone through a lot of the first few terminology lines here, but what if we want to actually get the latest version of the code from the server or the remote repository that Leela's been talking about? Now that's where pulling comes in. And essentially the command pull is used to receive data from GitHub or any other remote hosting platform, so like GitLab or Bitbucket or SourceForge. There are so many out there. And it essentially fetches and merges the changes on the remote server to your working local directory. And we'll look a bit more into fetches and merges a bit later, so don't worry about that terminology just yet. And now we really start getting into the really exciting bits of the really exciting part of Git, in my opinion. And with we're looking at branches, merges, and pull requests and other such things. And this, I think, is where you really start to see why Git is set as a golden standard for code collaboration in the tech industry nowadays. So a branch, what is a branch? Well, essentially a branch in Git is a version of the repository that diverges from the main working project. It's essentially a feature available in most modern version control systems, and a Git repository can have more than one branch, and we can perform many operations on Git branches like rename, list, delete, etc. And when you make a repository, there's one branch by default. Now, this branch is traditionally called the master branch, but as of the 1st of October 2020, all GitHub repositories will now have their master branch named main instead. Now, this was a move made by GitHub, who's owned by Microsoft, to remove some unnecessary references to slavery and make the terms more inclusive. So say we want to add a new feature to our project, but we don't want to break the existing code that we know is stable. This is where we might want to use a branch. So essentially, a branch takes the entire code base and makes a copy of it. Then you can modify the code base without breaking the stable version of the code on the main branch. So say, for example, you're adding a new navigation bar to your existing website. You can make a branch of the main repository and then add the new nav bar to the branch copy of the code, whilst other people might be working on other features of the website at the same time in separate branches, in their own separate branches that they've created. And when you're ready, you can add your fancy new nav bar back to the main branch so it's active on the real website. Now, how do we integrate these changes that we've made on the branches back to the main branch on the live working website, for example? How do we do that? Well, in this case, you'd want to merge your navbar branch with your main branch. Now, you can technically merge any two branches, but it doesn't have to be with the main branch. That's why merge graphs can actually end up looking really quite confusing. So you can see here, there are loads of different branches, and they're all being merged into other branches, and then merged into other branches, and then merged back and forth, and then eventually it will be merged into the main line, or it might not be, so it might be dropped or something. And it can look really, really confusing, but seriously, don't worry. I promise it's not as bad as it looks. Meanwhile, so these are merges. Meanwhile, if you try to merge a branch that has code conflicting with the code on the branch you may merge to, i.e., let's say there's a change on both branches and essentially Git doesn't know which change to take, you can get a merge conflict. Now, these are arguably not so much fun, but also sometimes fun to deal with. But when you're working in a team on the same code base, you're bound to come across them from time to time. Sometimes Git can help you out and prompt you with exactly what you need to do. But other times you'll have to go in and fix it for yourself. Now, I think this graph back here that I quickly skimmed over is really good for understanding visually what merges are. Now, there are loads of features on GitHub, for example, such as the insights feature that we'll go into a bit later that show visually what your Git repository looks like in terms of branches. I think these are really good to look at and try and understand to get your head around it. Because if you're just learning all these words and you're learning it, maybe you're sort of trying to interpret it in your own sense, it can get quite confusing. So I think graphs are really good to both help you learn merging and learn branches, but also just to further sort of understand what's going on in your Git repository when it gets really big and really confusing. So if we look here, we start off with common base, and the time flow here is from left to right. And you can see this green branch, it sort of branches off from, so it branches off essentially from the, it branches off from the main branch. So the main line is the straight line at the top in blue, and each commit is represented by a dot. So you can see the feature branch, which breaks off from the main branch here in green, and then you have 3 commits on the feature branch. So you have the tip of the feature branch here. And after the feature branch has actually diverged from the main line, the master branch has also had 2 changes itself. So these 2 changes might be conflicting. So when they merge back here, when the feature branch merges back into the main branch, so let's say the main branch is where it's on live production, like your live website, there could be conflicting changes. And so you'd have to deal with this with merge conflicts. And again, we'll go into that later, and we'll also do a live demonstration of a merge conflict and how you fix it. And you can see here a new merge commit is made on the main line, so it's a blue commit, so it's a master mainline commit, and then it will keep on going, and then you might make another branch and diverge from that, and you might have a branch and then have a branch after that branch, and that's, as I said, was why it can get really confusing here. But again, if you're sort of working on your own repository, you'll usually have an oversight and you'll be in control of what's happening, and so it will make sense as you're doing it. So I think it's also good to talk about good ways to actually merge these changes to make sure that the new changes are good and aren't going to break anything. Now, this is where we look at pull requests. So a pull request is where someone asks someone else or multiple others to review the changes they've made in their branch before it gets merged into another branch. Now, this can help stop bad scenarios happening where broken code could end up in live production, like on your live website. So the navbar branch that I was talking about before, perhaps say you write this branch and you write a broken navbar and you try and merge that back to your main line, your main master branch, and it's broken, but you thought it wasn't broken, so you're fine, and you don't do a pull request, you merge it back, and you now have a broken navbar on your live production. That's not great. So you want to check with other people first before merging it back into live production. So that's what a pull request essentially does. Now, I think to understand the name pull request a bit better in context, because I personally found it a little bit confusing when I started learning Git, because you're not pulling from the remote repository to your local repository as you would with a pull command. I think it's better thought of as the person making the pull request is asking for their changes to be pulled into from one branch into another branch. So they're asking for their changes to be pulled into the remote repository. You're not pulling down from the remote repository. So now we've covered a lot of the terminology and theory behind Git. I think it's also it's a great time to go into a bit of a practical. So that's what we're going to do now. We're going to see a bit of Git in practice fully. So I think it's going to make a lot more sense. So this is where it all goes horribly wrong, but hopefully not. So what I'm going to do is, can everybody see this screen here with the practical Git slide on it?
Yeah, I can see it.
Okay, sweet. So if you can't see anything, just let me know in advance. What I'm going to do is I'm going to open Git Bash because I'm on Windows. Ideally, you probably want to be on Linux for this, or Mac. Probably the last OS you'd want to be on for this sort of thing. Windows.
Yeah.
but
if you are, Git Bash is great because it lets you do all the commands that you do on a Linux terminal. Yeah. Exactly.
So it's not exactly the same, but you can download maybe some binaries. So for example, I'll use a tree function in a bit that isn't native to Windows, but you can download a binary, which is exactly what I've done. So you can run all the Git commands inside Git Bash. So what I've done is I've opened Git Bash inside my documents repository, inside my documents directory, sorry, on my local machine. So this is just in my Windows repository. Sorry, I keep saying repository, on my Windows computer. You can tell I've been doing a lot of Git the last 24 hours. So I'm on my local machine in the documents directory. And what I'm going to do is I'm going to simply make a new directory as you would normally, and let's call it Git Workshop. So now we have Git Workshop inside our directory, inside our documents directory, and I'm going to navigate to that. So I'm going to do cd, change directory to Git Workshop. And now you can see this is literally just an empty directory. There's nothing going on here. If I do LSA, it's completely empty. So what we're going to want to do in order to make this a local Git repository is we're going to want to run the Git Init command. Now what this does is, as it says there, it initializes an empty repository. It initializes an empty Git repository locally. So now if we do ls, you can't see anything here, but if we do lsa, which shows a bit more of the files inside, we can see the .git file here, the .git folder here. Now, if we do tree A, we can actually see a tree of this directory. You can see .git has a load of files in them. And honestly, try not to overthink this. Try not to look into it, because honestly, it's complicated magic that we're not going to do anything with to avoid breaking it. So in general, the .git folder contains all the information that is necessary for your project in version control. And all the information, it contains all the information about commits, the remote repository address, etc. All of this stuff is present in this folder. And it also contains a log of your commit repository, your commit history, so you can roll back to different commits in history. So we don't have any commits yet, so we can't do anything with that, but we will soon enough. So first thing I want to do is I'm going to create a file called workshop.py, let's say. So I'm going to touch workshop.py, and now we have workshop.py as a file inside this directory. And I'm going to go over now to Visual Studio Code to edit this file and write some code in it. So if I go over here, ignore this was from before, Git workshop. So we go into the Git workshop folder. So if I close this, bear with me. As I said, this is when it all goes horribly wrong. Awesome. Okay. I'm just going to close this and save. Close this. Okay, so we've got an empty Git repository folder with just one file that we've created, workshop.py. And this is an empty Git repository on our local machine. So what I'm going to do is I'm just going to write a simple print hello world in this file. So it's just basic Python file. And you can see if I open up the terminal and run this file, it's just going to print hello world, hopefully. Yeah, there we go. So another thing I want to do is back in this directory, I'm also going to create a file called Readme. Now, Readme literally does what it says on the tin. It's a file that contains information about other files in the directory or repository. It's a standard for Git repositories. So you will see it in a lot, on basically all Git repositories. It's not absolutely, you don't need it. It's not required, but it's great to have. It's just a form of documentation, essentially. And it's just like a TXT file, but it's written in Markdown. So we're going to write a bit of stuff in this as well, just to populate it, get it going a bit. So it's Markdown, so we're going to write maybe DSC, University of Birmingham, Git workshop. And then let's write some information about the repository. So far we've got the workshop.py file in there. So let's say some instructions to run it. So to run this program, enter the following into a command line. And then let's say python.workshop.py is how you run it. So this is just a Markdown. So we've got this. We've created two files. We've modified them. If we go back to Git Bash, and now we run git status, we can see the two commands here. We can see the two files, sorry, here. Now, simply what the git status command does is it displays the state of the working directory and the staging area, and it lets you see which changes have been staged and which haven't, and which files are being tracked or not being tracked by Git. So Leela said a bit about this earlier with the commit theory. Now you can see both these files are not being tracked. Both of them are untracked here, and that's why they're in red. If they were tracked, they'd be in green. Now the staging area can sort of be seen as the place that files pass through in order in between being created and being committed to the repository's history. Any files you want to be included in the next commit, you need to add to the staging area. So that's what we need to do if we want to add these to the repository. We need to add them before committing them. So the git status command doesn't output any information regarding the committed project history. To do that, you'd have to use Git Log, which we'll see after we've made a few commits. If I run Git Log now, it's just going to say it doesn't have any commits yet, so it's not going to show us any history. So let's add them. I'm going to start off by adding workshop.py. So if we run git status again, we can see that workshop.py is being tracked. That's why it's in green, sorry. And readme is not being tracked. That's why it's in red. And you can see it being untracked here. And this still needs to be committed. It's been staged, but it hasn't been committed yet. So let's also add readme, just like that. And now if we do git status, we can see that both files have now been staged. So now let's go ahead and commit them, I think. So if I run git commit, I can put -m as an argument to write a commit message. Commit messages are great because they, when you're looking through the history, you can sort of see a description of what code changes that commit added. So rather than just being a bunch of code changes, you can see maybe something like this was the initial commit, which is a standard commit message for the very first commit in a directory. And it just says that we've sort of set up the directory. There's nothing really interesting here. We've just set up the basic files. So if we run this now, we'll make our very first commit, and we can do Git Log. And we can actually see some history now. Now before, Git Log was saying that you don't have any commits left yet, but now we've made a commit. We can see the commits here, and we can see the author, so that's me. We can see the date it was made, so that's like right now, and we can see the name of the commit as well. And we can also see the branch that we've made it on, and then this is the little hash that's unique to our commit. So what I'm going to do now is we're going to want to move these. We've made these changes. We've made these files on the local repository, but how do we put these onto the remote repository?
One second. Someone asked a question. Actually, it's a good question. So how do you link it to your Git account? Is the question.
Yeah. So there are some basic instructions when you first set up Git Bash. Yeah. So if you new install Git, there should be instructions online.
Okay. So you put your username, password, and it sets it up for you. So it's a personalized environment. Yeah.
Fortunately, a lot of things with Git are really easy to Google. So the setup of Git is really nice. So if you Google how to install Git, obviously my Windows didn't come with Git Bash. I had to install it. When I installed it, I set up my username and that like that. So that's why here it's set up with my name, and it knows my email, and it knows the date it was made, and the sorry, not the date. It knows my name and my email. So that's how I was doing that. And that's also how I'm going to hook up the remote repository, which I'm going to do now. So we want to make these commits from the local repository onto the remote repository. But how do we do that? You might remember from the understanding the jargon section at the start of the workshop that you would use the Git Push Command. But we haven't set up a remote repository yet. So if we do Git Push, it's going to scream at us. Git's going to scream at us and say, hey, I have no idea where to push this online. And so what we need to do is we need to go onto GitHub, and we need to actually create our remote repository online. So that's what I'm going to do. I'm going to go into repositories here. So this is just my username. This is my profile. So if you make a profile on github.com, you'll have something similar to this. And I can go into repositories, the repositories tab, and right over here in the green button, I can click new, and this will take us to creating a new repository. So I'm going to call this repository something like DSC Git Workshop. You can call it whatever you want. I don't believe you can have spaces in it. So, or you can, but it will automatically change it to hyphens. So it has to be hyphenated because this is a directory name. And then a little description about the repository. We can say something like, this is the introduction to Git and GitHub workshop at DSC University of Birmingham. And we have the option between making the repository public and private. Public, as it says here, anyone on the internet can see this repository. You can choose who can commit. So it's not like a free-for-all. So you still have control over it. It just means anybody can see the code on here. And you can also make this private. So you can choose who can see and commit to this repository. So if you don't want people seeing your code, because maybe you're working on some university assignments and you're copying you don't want anyone seeing copying your university assignment stuff, but you want to make a copy on Git just to make it backed up essentially, which is something I do. You don't want to make it public because you don't want people seeing you commit your code for your assignment. So I make that private. Now you can initialize your repository with a Readme file, which we've already created, so we don't want to do that. And you can also initialize it with a .git ignore file. Now the .git ignore file essentially specifies intentionally untracked files that Git should ignore. So say if you have some configuration files with sensitive passwords or tokens that you don't want to publish to your remote repository for others to see, you might add those specific files to the Git ignore file so they're not included in the commit staging. So they'll essentially always be ignored when you're adding and staging your files and you're committing them. Now finally, you can also add a license to say how people can use your code. I'd be a little bit careful about licenses because if you try and add one and you try and remove one, it can get a bit messy, and only really add one if you know what you're doing. That would be my advice. So we've done everything we want to do here. I'm going to go ahead and create the repository. So this goes through github.com and creates the repository for us. Now what GitHub is saying to us here is it's saying, you've made an empty repository, that's great. Run all these commands to make it on your local repository and link up your local repository with your remote repository. But as you might notice, we've done a lot of these commands already. The only command we sort of haven't done over here that we need to do is git remote add. So if you go over to Git Bash and we do git remote -v, essentially what this command does is it shows a list of URLs of remote repositories when you're listing your current remote connections. So it's currently empty. We didn't get anything returned from it. You should have something returned if you have remote repository hooked up, but we don't have any remote repository hooked up, so it's empty. So what we're going to do is we're going to take the remote link here. Now you can take the SSH remote if you already have an SSH key configured with Git, but I personally don't, so I'm going to do the HTTPS. I recommend using HTTPS if you want to make the configuration a little bit simpler, but SSH might be a bit quicker and a bit more secure. So we're going to be using HTTPS, and all I have to do, it's actually already set up here. So I can just copy this command actually and do git remote add origin, and then this is the link to our remote repository. And it's how our local repository knows where the remote repository is on the web. So I'm going to go ahead and paste this here, just like that, and we've now added it. It doesn't need to tell us that we've added it. We can do git remote v to check, and we can see that there have been two. So we can see that we've added this remote repository online under the alias origin essentially. So when we refer to it within our shell, within our Git Bash, we'll refer to it as origin, and you'll see that in a bit. So now we've hooked up the remote repository. Let's try doing git push. As you can see, it doesn't work as expected. Now, the reason for this is that we haven't configured an upstream branch, and you can see GitHub is fortunately telling us that we should have done this. So the -u is sort of an abbreviation for, it's a shortcut for upstream branch. So essentially what's happening is if we try to push without specifying the branch to push to, Git will yell at us. This is simply because you can have branches, you can have different branches on GitHub on your local computer. So you need to specify the upstream branch for our repository. And in our case, it's master, since that's the branch we're on. You can see it here. This is the branch we're on. Now, what upstream branches essentially define is they define the branch tracked on the remote repository by your local remote branch, also called the remote tracking branch. Don't worry if that doesn't make too much sense. Essentially, we just need to tell Git and GitHub which branch we're going to push from locally to the remote. So we're going to say we're going to push from the master branch. And to do that, we're going to do git push, as it says here, with the upstream branch for the origin remote repository as the local master branch. So master branch is our upstream branch to the origin remote repository that we just set up. So if you do this, it will both configure the upstream branch and it will also push our commits. Remember, we made that one commit, we made the initial commit. So now everything's worked successfully. If we reload this page, I think we should hopefully, yeah, we see there, our commits, our files that we made have been published online onto DSC Git Workshop, onto this remote repository. So this is the remote repository, and over here we have our local repository. If you do like ls, this is our local repository. And this here, all of this, is our remote repository. So we can see the Readme file that we created, which has been nicely formatted in the Markdown. And we can go into a file here like workshop.py. And you can see the code in here. We can also go into commits and we can see the commit history. So we've just got one commit so far, which is dated the 24th of November, and it was made 9 minutes ago. So what I'm going to do now is I'm going to go into this workshop.py file. And I'm going to actually edit it from GitHub rather than locally. So I'm editing it on the remote repository. And what is something that I could add? I could add like a function maybe called main. Don't worry if this syntax is new to you. It's just Python syntax. You don't need to know it to understand Git. It's fine. I'm just using it now because it's relatively simple. And maybe I'm going to write a function that says print. This function was added from GitHub. Simple as that. And now we're going to have to commit this change because it will essentially skip the process of staging because we're doing it through GitHub. GitHub makes things a lot easier. The reason for doing everything in the command line is A, it's a good habit to get into, and B, you can do so much more on the command line than you can on the restricted with sort of the graphical interface of GitHub. Yeah, it's nice and fancy, but I would really highly recommend getting used to the command line as soon as possible, as early as possible when you're learning Git. So we're going to commit these changes. Let's say with a commit message that says something like added main function, or just add main function. It's nice to have your commit messages in present tense. I think they make a bit more sense. And we're going to go ahead and commit it to the master branch. Commit changes. This does exactly what we did before with commit. It's just doing it through GitHub. And it's committed, it's saved. If you go back to code over here, we can see there are now 2 commits, one 11 minutes ago and one now. We can click on this to see the commit history. We can see there's the initial commit and then the add main function commit. And so if we click on this add main function commit, for example, we can see the changes. So this code was added and this was deleted. I don't know why it's really saying this, because we didn't really do anything to this, but what it's saying is basically that this is the new code and this is the old code. So if you deleted some lines, they'd be in red. If you added some lines, they're in green. So now if we go to Git Bash and we do cat, so essentially prints out the content of workshop.py, what would we expect? Now what you might say is we'd expect everything here because we've updated it. If you do cat workshop.py in our local repository, you notice we'll only see print hello world. We won't see everything we just added here. And the reason for that is that the local repository isn't up to date with the remote repository. We haven't synced the files yet. This is what Leela went through a bit earlier when talking about git pull. We need to pull our changes. Yeah, we need to pull our changes in from the remote repository into our local repository now, which is exactly what I'm going to do. So if I do git pull, we've already set up the master branch. We've already set up the upstream branch, so we don't need to configure it again. We can just do git pull. It knows exactly which branch to pull from, and it pulls it perfectly fine. Now, if we do cat workshop.py again, we'll see the changes. Perfect. We've now synced our remote repository with our local repository. And let's say now, for example, I want to make a change, but I don't want to break anything on the master branch because it's stable. We know it works, and we don't want to break it. So what I'm going to do is I'm going to make a branch for this feature, otherwise known as a feature branch in continuous integration terminology. We'll go into that a little bit more a bit later, very briefly. Don't worry about it now, but continuous integration is essentially the practice of multiple programmers working on the same code base, committing their changes, pulling, and just working with all those sort of horrible merge conflicts and that kind of thing. But yeah.
Yeah, there's a question now.
Go ahead. Questions?
It was, is the code now updated in the VS Code? Yeah, it actually is, because you've synced up your remote to your local repository, so it's changed.
So yeah, go ahead.
Yeah, you can. Is it? Yeah, there you have it. The functions.
So we're showing the Visual Studio Code here. I don't know if you noticed that, but as I changed over, it went from green. The really good thing about Visual Studio Code is it has little color indicators and letter indicators saying whether it's a new file, which I think is in green, whether it's been modified, which will then go into orange, and whether you delete the file or something. It's basically color coded because it's up to date with the Git repository remotely. So as you saw there, it went from green, which was a new file, and then it went or a modified file, and it went to sort of uncolor coded when I synced them. So it was sort of updating itself with it. So that's, I think that's a great question. Yes, Visual Studio Code is up to date with whatever's in the local repository. So if the local repository is up to date with the remote repository, then Visual Studio Code will be up to date. So if we make a change here, I think, so I don't know if I add brackets for whatever reason, I don't even know if this will work, and then I save it, Visual Studio Code will change this here to say this file has been modified. This probably is not, I don't think it's even good. Python, don't do this. But if we do git status here, we'll see that it's modified, so N for modified. So that's great. And then if we change those back to what it was before, it knows that it's the same as online on the remote repository, and it should remove the M saying modified, because this file right here is exactly the same as what's on the remote repository. So if I do git status now, it's sorry, I just typed that. It will say that everything's up to date with the remote repository. It's fine. It's all working perfectly. So as I was saying about the feature branch, we're going to go ahead and make a feature branch now to add a cool little feature without breaking the master branch, without breaking this code that we know works. And I can prove it works just by running main, maybe a call to main here, and then running Python workshop.py, and you can see it calls main, which itself prints this line here, so it works perfectly. But I'm going to keep it up to date with the remote repository, which is just like that. So in order to create this branch, this feature branch, we need to do a checkout command. But first, let's check what branch we're on. We can do that by running git branch, and we can see we're on the branch master, and there aren't any other branches currently in our repository. And to create a new branch, I'm going to run the command git checkout, which checks us out to the new branch with -b, which is just creating a new branch argument. And we're going to call this branch cool feature, let's say. Again, you can't have spaces in between, so we're just going to hyphenate it. And the great thing about what Git does here is it moves us to the new branch as well, which I think is really cool. So we do git branch here, we can see that we're now on the cool branch, cool feature branch, and also see it over here. So this shows us what branch we're always on. I don't know why it's gone over like that. It's a bit horrible. If you do git branch again, you can see here, this is the branch we're currently on. You can also see it here. And you can also see there's a master branch, which we're not currently on. We're only on the one that's highlighted in green with a little star by it. So we're now on this cool feature branch. It's made an exact copy of what's in the master branch, which is why if we go over to Visual Studio Code, it looks exactly the same. We're actually in the cool feature branch, but it looks exactly the same because it's just made a copy of the master branch. So what I'm going to do inside this cool feature branch is I'm going to make a cool feature. So let's touch a new file called coolfeature.py. This is just going to be an empty Python file. And inside this empty Python file, I'm going to write a bit of code. So let's write a bit of code to randomly generate a number, maybe between 1 and 10. So first, let's just import the Python library random, and then let's write a function called coolFeature, maybe, and return a random integer between 1 and 10. And then just to check this works, we can print coolFeature, run coolFeature, and you can see 8, 3, 6, 3 is generating random numbers between 1 and 10. So cool, that works. We've written this awesome cool feature on the cool feature branch. Now, if we do git status, we can see that there is an untracked file.
Yeah.
Yeah. So what do we do when there's an untracked file that we want to add and we want to commit? First, we need to stage it. So I'm going to do git add coolFeature.py, just like that. And I'm going to commit it with a simple commit message that we've done before. And let's say add function to generate random numbers. I think that's a reasonable commit message. And I want to update the remote repository now with this cool feature. So let's do git push. But notice, Git again yells at us. The reason for this is if we did this in the master branch, it would be perfectly fine with it because it knows where the master branch should push to on the remote repository. But here we've got the cool feature branch, and cool feature has no idea where it needs to push to. So we configure an upstream branch. And so in order to do that, we do the same as we did before. We're going to do git push, upstream branch, origin, and we're going to say cool feature because that's the branch we're on. I'm going to go ahead and do that. This pushes everything onto the online repository. Perfectly fine. It's awesome. And we can actually go over to the GitHub now, and we can see, we should hopefully see there are 2 branches. Yeah, which it shows here. And you can click down, you can switch between the 2 branches here and here. So we have the master branch, we have the cool feature branch. So if I switch over to the cool feature branch, we can see the cool feature.py, which is the file we just made with all the code we just added. What I'm going to do now is I'm going to go into the workshop.py file, and I'm going to make a few changes, I think. So we can see we've made more commits. So if you look at the commit history for the cool feature branch, we can see there are 3 commits. If we go to the master branch, there are only 2 commits. So we can see that because the master branch isn't up to date with the cool feature branch yet. So I'm going to go into the code for our cool feature branch, which is now uncolored. It's not color coded because it's up to date again, as I said. And I'm going to write a bit more code. So I'm going to remove this here, and I'm going to write def epic feature. Oh, should I say? Yeah, get epic feature. I think I'm going to just make these the same. So I'm going to say get cool feature, and we're going to return this is an epic feature. And then let's write, let's write maybe in the workshop.py file. Let's change a few things. So I'm going to import the code from the cool feature file now. So I'm going to import cool feature. So this imports from this file here. And I am going to call these functions and define a cool feature.py inside the main function. So I'm just going to write print cool feature.get cool feature, or cool feature, and also print cool feature.get epic feature. I also made a typo right there. I don't want to do that. And let's do a call to main just to see if this works, and then run Python main, run Python workshop. There is no attribute epic feature. That is because I made another typo. That's fine. We can fix that. Go back to workshop.py, run it, and awesome. You see that we still have the random number generator, and we're also getting all the functions from the cool feature.py file inside workshop. So that's cool. We can now go over to Git Bash, run Git status again, and we can see this is interesting because we've modified these two files here, which is cool and dandy, but we've also got this annoying thing called PyCache, which we don't actually want to track in our repository. It's useless for us, and the thing is it'll constantly change, and this will eventually become quite annoying. So I'm going to add it to Git Ignore File. So this is good practice to show you what the Git Ignore File does. So I'm going to touch .git ignore here. This creates a Git Ignore file, and inside here I'm just going to write PyCache, which is the file we want to ignore. It's just a list of files that we want to ignore in tracking. So if we do Git status again, you can see now instead of PyCache we've got Git Ignore. We don't have PyCache listed here because it's being ignored within the Git Ignore file. So this is great. We can now add. So what I'm going to do here is I'm just going to so that when I look back in the commit history, I can see that Git Ignore was added on its own. So I'm just gonna stage Git Ignore on its own here. So it's the only staged file, and I'm going to make a commit exclusively for Git Ignore. So I'm going to say maybe added the Git Ignore file, and then the second -m argument essentially adds a description to the commit. So it's optional, but I'm going to do it here just for demonstration purposes. I'm going to say ignoring the PyCache directory. So here we've just made a commit for the Git Ignore file, only staging the Git Ignore file, as I said. And as we've already configured the upstream branch, we don't need to do it again when we do Git Push. So that should work perfectly, I think. And then again, if we switch over to GitHub, we'll see in the cool feature branch, which we are in, let's switch over to cool feature, we'll see that there's another commit for the Git Ignore file, which just added the Git Ignore file with a PyCache line. So that's cool. Now what I'm going to do is I'm going to add the other files that I still haven't staged, simply using the dot argument. So I'm going to say git add dot, which just adds all of the files. So we can see if we run git status that all of the files have now been staged. And I'm going to commit with a message saying cool feature finalized, for example. And we're going to push. Now, if I merge this feature branch back into the main branch, there wouldn't be any merge conflicts, as Git would see exactly how to update the main branch, simply repeating basically the changes that we just made, because there's no difference, there's no conflicting difference between what's on the GitHub repository at the moment and what's on our local repository. But I think that's a bit boring, personally. Yeah. So what we're going to try and do is just really annoy Git as much as possible and create as many merge conflicts as we can so that we can try and fix them. So I think what we would do in this situation is if we wanted to merge the cool feature branch back into the master branch, it would be really easy. We could just check out to master, which goes back to the master branch. So you can see what branch we're in. We can see we're in the master branch now. And we would just simply run git merge cool feature, and that would merge it. But it's not what we want to do. What I'm going to do instead is we're inside the master branch now, so remember that. What I'm going to do is I'm going to create a cool feature file, as is in the cool feature directory, but I'm going to make it completely different. I'm going to make it as confusing as possible. So we're going to write maybe a function that just says confusing, that just returns confusing Git is great fun, for example, if you love confusing Git. We're going to write another function maybe called giraffe, and then say like, I'm not really sure why this is here. And then if we go to workshop.py and we change this thing from was added from GitHub to I don't know, wasn't added from GitHub, because I mean it technically wasn't. And also I'm going to add the import below the print statement, which is not something you should do in Python or general coding practices. It's bad. You should always add your report to the top of the file unless you have a really good reason not to. The only reason I'm adding it is because the call feature, the import call feature was at the top of the file, the call feature file in the call feature branch, but it isn't here, so it's hopefully going to cause a bit of merge conflict. And then inside main here, I'm also going to write a print to call feature.confusing and a print to call feature.giraffe. And if we run Python workshop.py, this should hopefully just be fine. No module named call feature.py. Whoops, that's because I put .py in the import, which is not what you should do. And there's not printing anything out for call feature. Not sure why. Call feature return. I think we have to put print here.
Yeah.
I think I know why. Okay, well, we'll try with print here. Let's try that. No, confusing is very fun. Dot confusing. Cool feature. Workshop require. What if you can move this back up here? Does this fix it? Import cool feature. Not really sure why this isn't working. Am I blind? Cool feature dot confusing. This isn't too vital anyway.
Yeah.
Oh.
You're not printing it.
I don't think printing is the problem. That's fine anyway. There's no worries. So, it's because I'm not calling main, that's why. I don't know if people are screaming it. There's probably someone screaming behind the screen. There we go. So we added the main call, so we're calling this function. We were previously defining a function that we were never calling, which is why I wasn't printing. But here we've called the main function, and you can see it's printing everything here. So awesome. We've made a master branch that is completely different. It's sort of similar, but completely different from our call branch. So now it gets to the fun stuff. Let's commit these changes. So we're going to do git status. We can see there are files to add. We're going to ignore PyCache there, so we're just going to add these two files. We're going to pretend that PyCache isn't there, and we're going to make a commit, saying add confusing functions maybe. And you can see they've now been committed, so they're not in the staging area. And we're going to push because we've already set up the upstream branch, which means as it's pushing, we can go over to Git, and this is when it starts to get a bit fun. We've made the push, and we can see that cool feature has had pushes, master branch should have had pushes actually. I also realized that I made a typo here. We're going to pretend that isn't there and that I spelled university correctly because I definitely didn't make a typo. So made git push. So if we refresh this, it should hopefully be up to date on the master branch. So if we switch over to the master branch that's on the GitHub, we can see that we have the option to compare and pull requests. So we made a change on the master branch, and we can now pull the cool feature branch into the master branch, which is what we're going to do. We're going to click on this. And we could alternatively use the terminal, but here I'm going to merge it using the GitHub interface because I think it's nice and visual, helps you understand it a bit better. And as you can see, it says can't automatically merge. Awesome. It's probably the only time I'll be happy to see a merge conflict. So it's don't worry, you can still create a pull request. It's just there are merge conflicts that we need to fix. So exactly what we're going to do. We're comparing the cool feature branch. So we're merging the cool feature branch into master, which is correct. So we check these first, and we can write a little message for the pull request. Now I'm going to write something like add cool feature to main, and you can assign reviewers down here. So if there are other people collaborating on the same work, you can add them here, and you can also add labels for the pull requests, etc. But we're not going to worry about any of the stuff over here. We're also going to write a little description for the imaginary reviewers, which is literally just myself, which is a little bit sad, but we're going to pretend that's not happening. And we're going to write a little description about this pull request, maybe saying cool feature has been added to the project. Hope you think it's as cool, really creative with the words here. It's as cool as I think it is. Boom. Sweet. Okay. We've done all of that. Now we can create pull request. So that's exactly what I'm going to do. Click create pull request. Now we just have to wait. Okay, awesome. We can see down here, this branch has conflicts that must be resolved. And if we click on resolve conflicts, you can see the merge conflicts within GitHub here. So these are the two files over on the left, and in cool feature apply, which is what we're in right now. GitHub is essentially telling us, hey, these are the lines of code that I got from the cool feature branch, and these are the lines of code that I got from the master branch. They're different, they're conflicting. Which one do you want me to add? Do you want me to include this one? Do you want me to include this one, or both, or neither? I don't know why you'd want neither, but which one do you want? And same with workshop apply. This is from the cool feature branch. So this is the code that is the same on both branches down here, but this is the code that's on the cool feature branch, and this is the code that's on the master branch. Which change do you want? So rather than doing it here, we're actually going to switch over to Visual Studio Code, and we're going to fix them here. So the way we're going to do this is if we go into pull requests actually, and we go onto our pull request, and we scroll down here, there's a little link that says view command line instructions. This just gives us some idea, some help to fix merge conflict on the command line. So I'm going to run these commands. So I'm going to start off in the master branch by doing git fetch origin. So you might be a little bit confused about the difference between fetch and pull. This will probably take a little bit more time to explain, but simply git fetch is like pull, but it does a little bit less. And essentially, git fetch is a little bit safer than pull, and you can never really fetch too many times. So don't worry about using git fetch. Maybe be a bit more careful with git pull. But git fetch is what we're going to use right now. So we're going to fetch the stuff from origin, and now we've fetched. The next line says is to check out to the cool. So we're going to create a cool feature branch. So what GitHub's doing here is it's basically talking to me like I don't already have the local repository on my computer, but I do. I've already created the local cool feature branch, so I'm going to ignore this. I'm actually just going to check out to the branch that we've already made, which is called cool feature, which we can see switch to here. And we can also check with git branch. And I'm going to now merge from master into the cool feature branch. So what's happening here is, you might want to think back to the little diagram I showed earlier, is essentially merge. So master had its changes at first, cool feature diverged from master. Now we're pulling the changes from master that we made whilst after the cool feature branch had diverged from master, and we're now merging those changes back into the cool feature branch. So we're making the merges inside the cool feature branch. So everything will be fixed inside the cool feature branch. What we need to do after this is we'll then need to merge the cool feature branch back into the master branch. So don't worry if that makes not so much sense. We'll take it step by step. So what we're doing right now is we're merging the master branch into the cool feature branch. So to do that, we're in the cool feature branch. We're just going to write git merge master. And as you can see, there are a bunch of conflicts. There's a conflict in the workshop PI file, and there's also a conflict in cool feature PI file. So as the person, I'm not sure your name, sorry, because I can't see the chat, but whoever asked about is Visual Studio up to date? Yes, it is. And you can see right here why. You can see I've made this merge, and immediately Visual Studio Code is going, hey, how would you want to sort out these merge conflicts? So we're going to do them right now. We have the option between accept current change, which is this one, accept the incoming change, which is this one, or accept both changes. So what I'm going to do is I'm actually going to accept both changes, which leaves both this code. And you might be able to tell if you know any Python, or just really any programming in general, this is a mess. So I'm going to sort this out a little bit. I'm going to move this print statement up here. And I am going to delete the duplicate main function call and move everything from here to here. So that's hopefully fixed the conflict in the workshop.py file. If you go to cool feature, we also have merge conflicts over here. So I'm also going to click accept both changes. And I think this works just fine. If I put maybe a space here, just to make it look a bit nicer, that should be fine. So if we run Python workshop, this tests my live programming skills. And hey, sweet, we still have the number generator here. We can see it's printing hello world at the start. Then it's printing the function from GitHub and the 5. So essentially what this has done is it's merged all the stuff we made in the cool feature branch and all the stuff we made on the master branch. They've merged back into the cool feature branch. So everything is now working perfectly inside the cool feature branch. So now all we need to do is we need to merge this cool feature branch back into the master branch. So what we're going to do is I'm going to make a commit for this. And you can see if I do git add and I do git status, you can see now I've staged both of these commands, both these files. If I do git commit now and say that the master branch has been merged with the cool feature branch, and that is sweet. Now if I do Git Checkout Master, so I just switch over to the master branch, and you can check we're in the master branch here, but you can also see it on the right as I said before. And now we just want to merge the cool feature branch back into the master branch, because at the end we really want everything in the master branch, because the master branch is where our live production of the code is. So let's do that now, just as we did before. Git merge. We're already in master branch. We just want to do git merge. No FF. Now I believe no FF is short for no fast forward. Don't worry about this too much right now. Just some Git stuff. Don't want to overcomplicate the unit right now. So if you're understanding everything up here, that's amazing. And we're just going to merge the cool feature branch into the master branch. So we'll run this command and hopefully we get a little Vim thing. I think we get a little notification, but fortunately everything we've already fixed the conflict, so we don't need to worry about this. I'm just going to exit out of Vim with save and quit, and everything hopefully, yeah, you can see the merge has been made. So this will automatically make a merge commit. But again, everything's been happening inside the local repository, so we want to keep that up to date with the remote repository. So what we're going to do is just make a git push, and I think this should work, but we're going to do origin master just to be sure. So git push from our master branch onto the origin, the remote repository, and that has pushed fine. So now if we go over to GitHub, you can see this is updated to merged already. Pull request successfully merged and closed, and it's also saying you can delete the cool feature branch optionally. This is useful if you're adding loads of features with loads of different branches, because you might not want any redundant old branches hanging around to sort of make the repository neater and easier to manage and maintain. But I'm just not going to bother with it for now. So if we go over to the code tab here, we can see that in our master branch we have the cool feature file. I'm going to quickly fix this typo with one quick commit, just because it's annoying me a little bit. University, and just fix typo, commit changes as quick as that. And the master branch, if we go into the history of the master branch now, so code, we're on the master branch over here, and we go into commits. There are 9 commits. Now, if you notice, this was the commit. These were the commits we made on the master branch, but these were all the commits that we made on the cool feature branch. But they've been merged into the history of the master branch. So it's taken all the commits on the cool feature branch and merged them into the commit history of the master branch, because it's now the same code base. And you can see Git has also made a little merge branch cool feature commit for us automatically, which is just merged files. Now, a cool thing to look at is if you go into Insights and you go down to Network, we can see this graph that I've been waving my hands around trying to describe. We can see that we had the master branch here, and I made it within the initial commit. And this is each dot represents a commit. So we can see here I made the main function, and then I made a copy. I made a branch for the cool feature branch. I'm going to zoom in a little bit. Can't scroll along. Why is it not happening? Okay, so we can see that the cool feature branch diverges from the main branch here. And while I'm making commits to the cool feature branch, I also make this horrible merge conflicty commit to the master branch. And then I have to merge from the master branch back into the cool feature branch. This is where I fixed the merge conflict, and then I merged all those fixed merge conflicts back into the master branch. And this is where we're at. So that's pretty much it for going through everything from your first commit all the way up to dealing with merge conflicts. One link I do want to share with you, which I'll put in the chat, and if anyone wants it after, either take a note of it now or save it later. This is an article I used extensively throughout my internship over the summer, where I was working in a team using Git collaboratively with having to handle merge conflicts and all the rest. And basically, if you're working in a team doing continuous integration and you have loads of team members all working on the same code base, you want to have some sort of consistent workflow. So this is the workflow I used. I'm not saying it's the only workflow. There are plenty of workflows that might work better for one team than other teams, but I think this is a good read if you're new to thinking about working in a team, which is useful for things like hackathons. And you can see there are little things down here. So this talks about sort of making the different branches. So in a continuous integration workflow, you might have a master branch and then a staging branch and then feature branches. So basically the staging branch in between the master branch and the feature branch that we talked about is where you might merge the feature branches into together to see how they work together before you put it live production, because you don't want to start merging these feature branches straight back into the master branch if when they merge back they sort of break. So it's sort of like it's an intermediary branch that lets you test what you're adding before you actually make it live, which is a bit more serious if you're working in a team, maybe on an actual deployed project with customers, for example. So this is just a really good read. I recommend it. I'll post it in the chat now if I can, just there. And yes, Justin was just mentioning about Git restore. So there's actually a nice little graph in here that shows the command, so the workflow that I've just talked about. So you can see here, when you're committing, you use the git add command, which takes you from the workspace, stages your changes, and then in order to commit them, you do git commit, which commits them to the local repository, and then in order to publish them to the remote repository, you use git push. And then if you're working the other way around, you might use these commands. So if you're pulling, you use git pull to get the code from the remote repository down to the local repository. Then if you want to remove commits that you've maybe made, you might want to run this command here, which resets the head and removes sort of the top level commits that you've made and brings them back to staging. And then if you staged files but you want to unstage them, you just git restore staged, and that could restore it from being staged to unstaged, and that is how you reverse stuff, because Git sometimes can be seen as like sort of one way, and if you make a commit, you can't undo it, which can be a bit confusing and it's a little bit scary sometimes. But you'll get a hang of it with practice, and I hope this workshop gave you a bit of foundational knowledge so you can go ahead with your path to learning and mastering Git. And I think this quote, which actually I credit Justin for, and I credit Justin for a lot of these slides because he made them for a workshop that he ran last year for developer student clubs, and I really appreciate Justin letting me use these, and also Will, who sort of let me use some of the examples for this workshop. And I do really like this quote. It's easy to shoot your foot off with Git, but also easy to revert to a previous foot and merge it with your current leg. So I think this quote perfectly, it's a perfect quote to end on. Thank you so much for coming to the workshop, and I really hope you learned something. With regards to DSC, look forward to some announcements coming soon about upcoming workshops. So it'll be on topics such as React, Flutter, plus many more. If you have any ideas or want to potentially get involved in some way, feel free to shoot me a message on Discord or on Twitter at robj3d3, or you can just do a search for me on Facebook and send me a message or send me a friend request. And that's about it. I hope you have a great rest of your week, and thank you so much for coming. Oh yeah, and if you have any questions, shoot them to me on Twitter as well if you want.
Thank you.
It's great, thank you.